Well, welcome aboard, everybody. Thank you very much for joining us today for Markham's latest webinar episode, Unpacking British Standard 8102 2022, Part 2. In this segment, we're going to be talking about the standard in practice, risk assessment, causes of failure, specialist consultants, and a team approach. On the call, I have here with me in the room at Napier, we've got Hayden Prestidge, Markham, and joining us is our guest from Auckland, which is Stuart Tansey of Newton Waterproofing.
How you doing?
You want to give us a little bit of background about yourself, Stuart?
Hi, Stuart Tansey. Been in the industry about 27, 28 years now. Basically, most of my career has been in waterproofing, originally on the tools and then sort of worked through into design side of things. Worked with Newton Systems in the UK for the last 14 years, and then came over to New Zealand a year and a half ago, where I've continued the Newton brand and the philosophy, bringing the internal cavity systems to New Zealand.
Brilliant to have you on, Stuart. And it's really leaning on that British experience as needed in both Australia and New Zealand. So that's good.
Very good. Before we go any further, I take it that everybody's hearing okay. Do you want to just put on the chat just a yes to confirm that we're audible? Really great to hear from you.
Righty, there we go.
All good. Thank you. Thank you for everybody contributing. All right, down the bottom right of the screen, excuse me, is a little circle marked questions. And we'd be very grateful if you any questions you have as we go along. We'll have a session at the end where we talk through those. And just as a last welcome poll before we head in, can you tell us if you've been working very recently on basement projects? Have you had a recent basement project? And if you want to share any challenges, we don't mind seeing those too.
Yeah, back that. It would be good to just pop in the chat if you've what role you play in waterproofing, whether it be designing or installing or whatever role you play through there. And then, any challenges like Brendan said, because it's always good to get to the actual challenges that people are having in the industry.
Can I just add, if anyone's been using 8102 as a guidance for their design as well, what sort of response you're getting? Because obviously it's not an official standard in New Zealand and Australia, but a lot of people are using it as a guidance document. And there's a mixed review in terms of some designers and clients are accepting it and some aren't. So it'd be interesting to hear how you guys are getting on with using the standard.
Thanks, everybody. While they're coming in, we'll just have a quick review of what we covered in part 1, in which we went over what is the standard and why is it significant to the industry in Australia and New Zealand. As Stuart just said, it's not actually official here. And then we talked about grades of environmental levels of risk, and we talked about the types of waterproofing. So Hayden, if you'd like to take us away for the learning outcomes of this session.
Brilliant. Thank you. And welcome aboard, everybody. Thanks for taking a little bit of time out of the day too. It's always good to see people committed to keep learning, keep developing, and keep your industry on the up, getting better. And that's what it's all. This session's really about: is the need for success, the need for successful projects, and but the big thing we really want to focus on is below grade structures. Obviously, that's British Standard 8102, and so we're going to jump into some of the pain areas, I suppose, the challenges. What's some of the things we're seeing? Why are things failing? So we'll have a look at that. What the key causes are there, and then what steps we can take to reduce that risk and get it better from the start, and work as a team to ensure we're in successful projects. There's a need to do more in the industry. I think we're all aware of that. Whether we can be guided to, put the effort in up front and get to that point, just get things right. So awesome comments coming in. Really appreciate it. It's good seeing what people are doing, from inspections to different engineers, facade engineers, water. There's a huge industry, and we need it to. We all need upskilling together. So let's jump in and have a look at what's going on. So defects do happen, and that's reality. And we do need to think about that. It is painful, and it does cost us a lot, not only monetary, but you got to think about our reputations, our brands, our time. There's a lot of effort, a lot of headspace, those sort of things. But we've got to think about where they come in. Ideally, in an ideal world, obviously, it would be defect-free, and everything would truck on just as built, as planned, and that's it. But you got to think about some of the things taken into account, some of the uses for the design of the building. What could it be down the track as well, or what's the water table going to be in 5 years when other buildings around it, these sort of things, and they do affect defects. So just quickly, obviously you can get defects in design, and then defects in workmanship, so the quality of the installation, and then defects in the materials themselves or the selection of materials, those sort of things, and then follow-on trades or the site, what happens next after the waterproofing trade's going on. But Stuart, you got some pointers on this slide?
Yeah, I think, as designers, we've got to adopt to change the changing conditions. And I think some of the biggest talking points obviously are climate change, the change in where we're building, because of the need for space. We're building in places that we would never really have built before, especially here in New Zealand, a lot of reclaimed land. So you're dealing with high water tables, contamination, and then the ever-increasing rainfall is changing those conditions on a weekly, monthly, yearly basis. So these defects are inevitable, and it's great that the 8102 basically says you need to design to assume that defects are going to occur. And there are a couple of new points in the 8102. So you've got to expect the poor workmanship. You've got to expect, the material use. But I think the biggest ones that weren't in the previous was the follow-on trades, which is inevitable. Putting in an external system and then having, especially on a large commercial build, having a load of steelies going around, putting all the steels in. How can you guarantee that there's going to be no defects once they leave? So it's really about putting in a contingency at the design stage and making sure that the whole design team are on board, knowing that it's not possible or realistic to expect 100% perfection, especially with the external side and after the follow-on trades, and then just making sure that contingency has got a fail-safe, that if there is a defect, that you can get back to it, that you've got form and feasibility. Or if there's no defect, the 8102 goes on to say maybe look at a combined approach. If the effects of that defect are such that it's affecting the internal environment, then you need to consider a combined solution. But also ways to mitigate those defects. Communication on site, planning ahead. Minimizing the way you build. For example, instead of just pouring a raft slab, put a kicker on it. So mitigate those potential defects that are going to come in the future.
Oh, that's really good. And I just want to reiterate that point and it's a big part about the 8102, isn't it? Is potential for the defects, thinking about that right from the design point of view, and that taking account to the design and considering repairability, like you said. If there is a defect, how can we repair it? Can we still access that point that we need to get to that repair? So there's some of the things we need to consider in the 8102, but for every project. So as we said, key causes here, poor workmanship, the inappropriate product choice, but it could also be product itself, and then the ongoing trades not listed there as well, but that is a
Mm.
key consideration and something to mitigate. And like Stuart said, a round table at the start of a job with all the trades, all the associated trades, potentially if we can, the follow-on trades, really honing in on that importance and getting it right. But any other
Yeah.
points on that?
I mean, another one is defects by design. I think you mentioned earlier, which previously wasn't sort of brought into the fray with the last BS8 102. So defects by design, which means that designer can be held culpable, which is why it's so important to have a specialist on that design team, even as an advisory point, so that they can influence that design. Any changes in that design can be looked at, any product changes, compatibility, all of the areas where potential failure or defects can be caused. It's a massive part, probably one of the biggest parts of 8102. This and client internal environment.
Yes, agree, and it's probably a big part of our builds actually at the moment. Not the build, but the ongoing effect of not getting it right, and whether we can just have a stop and rethink. What can we do at that earlier phase, right down to our methodology of build. Like Stuart said, putting a kicker on a slab. Okay, it's a little bit more work at the time, a little bit more design level needed, but it's going to make the difference. So, no, that's really good. It's good you mentioned specialist consultant. That's
it'd be interesting to know how many design meetings at the end of selection and going through that whole process actually sit down and talk about defects, the potential for failure, and then put in a plan. And it's probably something that's not talked about enough, and how to mitigate or how to further protect the system long term.
Yeah, especially thinking, we've all seen that where misplaced services or something, and you've got to call through. Just thinking about all these things and making sure we've got a plan. Yeah. That's real good. So trust us is following. Everyone's following so far. Please put questions in. We've just talked about the pain and some of those failure areas. So pop questions and then we'll get to them at the end. But just gonna hone on it. And it's probably one of the key updates, wasn't it, Stuart, through the 2022 edition was the need for a specialist consultant. And traditionally, and it's still a big part of the game now, architect, engineer, and there's a number of you on the call, which is great, and you've been loaded with the task of designing a waterproofing system, and and then thinking about how it interfaces with the building itself, with the structure, with the other products that are needed in the build, claddings, etc. And now it's a big part of this 8102 is bringing a specialist in that looks at it right from the early phases, right from design, right from the risk point of view, ground conditions, building methodology, and then obviously helping with the design process. So you are a CSSW or certified surveyor and structural waterproofing yourself, Stuart. Tell us about it. Tell us about the role.
So CSSW, so within the UK, and in this document now, it recommends, suggests that a specialist waterproofer consultant should be involved with the design, preferably having the CSSW, which is a certified surveyor and structural waterproofing. There's also a second one, which is a WDS, waterproofing design specialist, which is, I suppose, it's a slightly higher, it's a more experience, more professional experience, etc. But the idea is to have someone on that design team that understands the project, knows how to move around a construction site and understands the complexities of it, that can influence the design. As I say, it doesn't have to be, especially because here in Australia and New Zealand we don't have the qualification yet. I'm hoping something like that will come in, but at least someone that has long-term experience with products, with practical as well. So understanding, for example, when a site's finished, external membranes in, what do you do with the supports when they come out? When the crane pit comes off, how do you detail that? These are all little bits and pieces that are going to potentially cause failure long term, but a specialist will understand and see at design stage and know how to put that within the program as part of the design. So it is important having a specialist that knows waterproofing and not just someone that has done it before and knows a particular system that works from in the past.
Yeah, that's right. But they're actually taking on part of the risk, aren't they? You know,
Absolutely,
they're becoming part of the building. They're got PI cover, for design point of view, these sort of things. So it's good. But probably a key part is they're coming in early, where we've really lacked in Australia and New Zealand, and where the 8102 helps is that early engagement. And
yes.
in Australia and New Zealand is often we've seen that, the building's half or 90% design, not quite that level, but, and then we start thinking about how we're going to waterproof it. That's extreme, but we do see that type of activity, and that makes it very hard to get things right, doesn't it?
Yeah, I mean, it's recommended that it comes in at the technical design stage, or the REBA stage, and over here I think it's stage 4 in New Zealand. But having that input at that stage, I mean, the proposals can be put forward, but then having that specialist come in and say, oh, well, with the type of structure you're recommending, this type of product isn't suitable, or with the ground conditions and contamination, you're going to need this. So it's just giving that bit of experience and knowledge that they built up over many, many years to make sure you put it in the most robust system. But I think one of the biggest things I've noticed not having a standard is the lack of availability of other products, innovations, being able to bring in, type A, type B, type C, mix them up, and making sure that they've got every opportunity for protection long term, not just products for the short term. And having that specialist involved who know these products and techniques that are available. Yes,
and has a spread in a range of products, doesn't it, or systems?
Absolutely, yeah, absolutely. And again, that's why a standard needs to come in. My belief is because it does it opens up to a whole range of different options rather than just a single track type, if that makes sense.
Yeah, no, that's really good. And the importance of a team approach, I think, is we've mentioned a few times on here already, early engagement, but it's not necessarily a contractual engagement. I just want to make that point. It's more about, as you can see in that picture, getting your heads around the table, looking at the concept of a building early. What's the future use? What are we trying to build? What level of protection do we need? And become part of that design team early, and just really getting in and increasing our chances to have a really successful outcome. But you've been involved in these, Stuart?
Yeah, absolutely. It's vital that you've got a team approach, and that goes from geologists, structural engineers, architects, even a client in some cases. But it's to be able to put all that, because we're experts in one particular field, and then just having that team approach allows you to have those conversations and get some continuity in design. What is feasible, what isn't feasible. So it's very important that a team approach is always part. And it's I think, Brendan, we've got a figure 1 from 8102 is a really good table that you can use. It's going to bring it up in the risk assessment, but it's a really good table you can use when you are within your team at the design stages. It allows you to go through the table just to make sure that everything's covered, to look at points that aren't covered, and then we've got it coming up. So it gives you a fantastic guidance, and it takes you through the complete design, basically. And as I say, it just brings a team together, and everyone's got a job involved in that initial information with that design philosophy, that then once it's put together, once all is agreed, and once the most robust solution is found based on that design philosophy, then you can go through to looking at your type of structure and your type of products. But a team approach is vital to the successful design. Yeah.
Yeah, and with the project outcome taking precedent, not there's no set way at all, because we've done this for years. It's
No.
what does the project need?
It's very open and clear. Yeah, it's very open and clear, and there's massive failures, which is costing money, heaps and heaps of money, and it can be avoided. Just by going through this initial information, and this has been put together by a lot of industry heads, especially and insurance companies, and different trades within the industry that impact below ground waterproofing. They may not do waterproofing, but they do have an impact on the design. So this will put you in good stead. I mean, even if it's just this you use at a design meeting, just to go through the philosophy to make sure that everyone's on board, and as I said before, the most robust system is chosen. Yeah.
No, that's real good. We will be, just for the audience, we will be doing a specific webinar purely based on this design flow chart or process, because it's very detailed. But it is very good to get our heads around and be guided by to get the outcome we need. So stay tuned for that one, but that will be coming. We'll dive into each one of those points and go through it. But yeah, no, it's real good. We've talked about the risk assessment side a number of times, so that we can have a quick talk about that. Sure, there's a lot that needs to go in. Not only touched on a little bit, not only what the conditions are right now, but are we thinking ahead further enough? You've mentioned the rainfall. We've seen displacement a lot. We're building or building a nice greenfield site. Next minute, or years later, that site, the surrounding sites are full. Really changes the water table. We're discussing a project just before, actually, where you're building up another one, up beside another one, you can almost form a cavity that becomes a swimming pool with water pressure against the wall. Are we taking these things into consideration, and are we getting the right people involved? So, any comments on that one, Stuart?
Yeah, mate. This is where your failure is going to come in, isn't it? When we talk about just picking a system that you've used before and just considering one form, but not also considering the desktop study and the risk assessment. And it just goes through all the different slides we've just covered, having that team approach, understanding what the constraints are going to be. But a risk assessment is very vital, because it gives you indication, recording water tables. Certain products will only resist certain head heights. It will allow you to understand the soil type, the drainage type. Additional drainage might need to go in to assist in removing pressure, contamination, movement. There's many things that a risk assessment and desktop study, and even you may be first on that site. 10 years down the line, that one building that you've built could be in amongst another 20 buildings. So it completely changes the status quo. So it's understanding with the risk assessment everything that's going to impact your design, not just short term, which I think where the issues lie, but long term, and considering the climate change, because you're changing the ground conditions as well now. So you've got to consider that within your drainage and your risk assessment.
I mean, we've even seen things where a basement has been half constructed, and especially in these quieter times, and then left for a period of time. And what's the long-term effect on those sort of things? Are we thinking about that sort of thing when we're going through design and phase? So there's a lot that goes into this.
Yeah, absolutely. I mean, the standard. I mean, what they say. I mean, you give the risk assessments. These are all good. It's good information, good advice, especially where contamination is involved. But you need to design to expect that at some time in that structure's life there'll be a full head of water pressure bearing against that structure. So in essence, we're always designing to full height. But more so than that, what's really good with the new standard as well, it brings and makes a point of bringing our waterproofing up to DPC level. Where when you're looking at risk assessments, when you're looking at water tables, one of the biggest issues you're seeing in the UK as well is groundwater flooding. But I think because it's not a nationwide thing. It happens very sporadically in small areas. It's not covered that much, but it's a massive problem. Grounds are becoming oversaturated. Water can't drain quick enough, and you're getting groundwater flooding. So risk assessments, you need to be able to understand the lay of the land, the soil content and everything, and make sure when you design and you're bringing up to DPC level, which is normally about 150 above ground level, and that should be where your waterproofing starts, and then down stops at the bottom, or stops, I should say, at the top.
That's a good point, because I think it was in one of the comments around the joint between a capping beam and a slab, but that was a key addition in the 22 edition, wasn't it, where they brought it up, and that is a responsibility of the subgrade waterproofing contractor.
Yes.
As to take the waterproofing up high enough to manage groundwater. So it's all these points.
It goes back again to the having the specialist involved. So without the specialist, they'd waterproof below ground, and that's the mindset. But a specialist knows that the risks aren't just below ground; you're coming up. So again, they're just little pointers as to the reason, to champion the reason why a specialist should always be involved in a design.
That's good. Pop your questions in. We'll get to them in half a minute. Can you just say something, Stuart? Obviously, 8102 design in Britain, they don't get a lot of seismic.
No.
But it is a standard to be guided by and to run us through these processes to get it. Can you just say something on that earthquake risk as well?
Yeah, no, I think in relation to 8102, I think that's where if there was going to be any changes to this document coming over to New Zealand, would be where that's impacted, or where that addition needs to be had. But also, we're not structural engineers, and there's a lot within 8102 that covers different elements of a building, or makes reference to, but also refers to different standards, such as concrete, EN 992. It's collaboration with other professionals that will, as I said earlier, impact or have an impact on the waterproofing design. And seismic is huge here. Something I didn't really understand much of coming from the UK until I'd seen some of the movement. It's just phenomenal. So yeah, it's just a matter of updating the 8102 to cover the type of environment we've got here in New Zealand, and then similar to Australia.
That's right, but in saying that, it's still dealing with the same aspects, really. It just comes as another risk to think about and design for. So
absolutely, and they're doing it very well here. I mean, the structures here have got an immense amount of steel in, movement joints all over the place, so nothing really changes. It's just bringing it up, making sure it's covered. And at the end of the day, water's water wherever you go in the world. So we're still protecting in the same way and doing the same thing. We just need to make allowances for that additional movement, which, as I say, they're already sort of doing here. It's just bringing them into the 8102 to make sure that it's thought about as well. It's part of the process.
100%. No, that's good. So just wrapping up. Obviously, we looked at some of the failure areas. What's some of the challenges? What are we seeing with the defects? What's some of the technologies that can be used? And then looking at that team approach was probably the key point there. That early engagement, that waterproofing specialist, getting into that design, and then really putting our best foot forward at design stage of the standard, which is a big part of the standard, we must add now, isn't it? Is that early upfront work.
Yes.
And then getting that through. So
it has to be. It has to be. For a successful design, it has to be. There's just so much information there from a specialist that can benefit. And as I said earlier, you got to look at long term. You got to look at sustainability, product characteristics. There's so many points there that a specialist will know and understand and be able to input into a design to make it successful.
100%. So there's probably a couple of questions sitting in there. Let's have a look at that, and feel free to, or please do, put some questions in there, especially around, I think Stuart asked a question earlier, what challenges have had you implementing the standard or discussing the 8102 with your clients or colleagues even?
Quite a number of in-depth comments have come in, which is really good. Wondering whether you wanted to touch on one or two of those points, Hayden and Stuart.
Yeah, there's a comment around the scope of waterproofing has always been a challenge, making sure the extent is sufficient to protect the building. I think that's really good. It is a challenge, and you got to be quite specific about what part of the building what we are focusing on, and probably loops back to what we were mentioning earlier. Is now with the subgrade waterproofing or 8102, bringing it up to 150 above the ground level. That's all part of the responsibility. So I don't know if you got any questions on that about defining this. Any comments on that, Stuart, about defining the scope of what we're waterproofing as well?
So say that again. I just completely missed it. I was reading the question there.
Yeah, that's all right.
Yeah. So defining a.
It's just there has been a challenge in the past, really defining the scope of what we are trying to achieve or what part of the structure we're working on, if you know what I mean. But 8102 helps us to bring it to bear, doesn't it?
Yeah. I mean, it's defining the scope would be. I mean, we're talking about entire below ground, aren't we? Up to DPC level. We're talking about anything that interacts with the basement. So not just a product. We're talking about the structure. For us, when designing at Newton's, we've always looked at the structure as your primary defence, and then you build from that. Even more so, I was just looking at Jacqueline's question there, where you're in a site where there's seawater and there's high water tables. That structure is going to be, taking the brunt of stuff. So it's making sure, you've got continuity between the drainage, your systems, and your structure to get your desired internal habitable space.
Yeah, it's a good question. That around the not necessarily a basement, but it's a slab on grade, but it's still the same aspects, isn't it? As to be affected. I think the risk assessment in 8102 speaks about the groundwater up to the bottom of the slab or up and over the slab. So you can take that same guidance and build it accordingly. But it's interesting what you say. You're close to close to sea level, so you're not going to have a lot of movement there. And then you've got to think about what's I don't know what the building is or where it's located, but what's next beside it? Is that going to lift the ground level or groundwater again? Those sort of things. So,
I mean, slab on grade. Yeah, I mean, we'd still take the same approach. You want a robust slab on grade, and this is where we talked about groundwater flooding. So groundwater resistance, and again, that's in 8102. So slab on grade, I mean, looking at, I suppose you've got to look at long term now. You've got to look at the way conditions are changing. A lot of houses being built slab on grade, no issues over many, many, many years. All of a sudden, we've got a climate change issue. We've got saturated grounds. We've now got slab on grades that are becoming wet. We've got moisture vapor coming up. We've got internal conditions that are needing remedial work, not just necessarily below ground. So slab on grade, I think, still needs to be protected. I think a membrane with decent concrete up to DPC level.
Yeah, I think we need to remember as well, concrete is a sponge really for anybody. It's full of porosity, and it will, people say, well, up the MPA will make it very dense concrete. It will wick water over time, especially if you put something on the surface of it, it's bound to get wet. So some of those considerations need to happen. Yeah, it's good question. Thanks. Trust that made sense. Feel free to put a follow-on question if something's not clear.
Another challenge here. Somebody's
Workmanship and application of a waterproofing system standard is always a concern, Stuart. It's a good question, good comment. The workmanship and the application. So just quickly, my 2 cents on that is it's very important to have obviously trained installers, but what is your quality management system? I think would be a big part of that, wouldn't it? So
Absolutely, absolutely. Yeah, so training first, approved status, and I think all manufacturers will do or are doing the same thing. It is a specialist area. It needs experience, consideration, and training. So yeah, I mean, all of our systems, for example, would be installed by an approved applicator. They need to provide insurances for their works. In the UK, they're backed up as well, so they've got 2 insurances: one for the general, and then an insurance backup, which covers the client. But yeah, I mean, again, it's slightly different because 8102, from where I'm from in the UK, the contractor is normally the designer as well, so they've got the PI. They understand. Or understanding a lot more of the process from the design stage. So not just being called in to put a product in a situation. Yes, they are trained, but having that full design and installation makes it a lot easier and less risk as well.
Yeah, and along with that, the need for a roundtable or that team approach again.
Yeah.
So does everyone understand what's been installed, how it's been installed, what's the methodology, when does it come in the program, those sort of things. It's very important, and it's a lot easier to have around a desk before you start than trying to remediate something that's
and also having that approved install involved at the design stage. If there is a failure, they'll know. They'll be able to deal with it. They'll be able to change the design as well to suit, because sites never go to plan. We know that. Things change. Clients change their mind. Internal environments change. Conditions change. So being able to be on the spot and be able to make that change as the designer and the installer is quite important as well. It removes any complications. As we would, our process, what you said, just the second part of that, our process would be Q&A. We would oversee the design. I have PS1 for design, so I'm in a position where I can be involved in that design. I would oversee, and then we would QA the whole process up until the point that it's handed over to client. So we would monitor and make sure that our contractor is comfortably,
Yeah, I mean, it's in the best interest too, isn't it? I mean, if you're involved with the design, you want to see it carried out how you designed it. So yeah,
absolutely.
That's a good point. Good question here on the new government decision to allow builder to essentially decide if it's a low risk, self-certify. It's a challenging one, isn't it? Exactly like you ask, what determines low risk for a start? I essentially see it as a bit of a loophole, but it'd be interesting what you say, Stuart, and how 8102 could support that.
I don't think it's it's not a low risk. I don't think you should be able to self-certify. I think it should still go through the process. It's dangerous. It's dangerous to be able to self-certify and then just put in a system. I mean, what you're saying then is that they're not approved. They're not trained. In most cases with these self-certifications, you'll get to a point where they're going to the shop and buying something off the shelf.
That's right. And it normally is thought about too late in those sort of situations.
But at the same time, there should be an easier route to be able to get that professional design, so it doesn't cost an arm and a leg, especially where remediation is involved. It should be a clear guidance process that design can be done properly by a professional to make sure that that client is getting a long-term dry environment and not just a product off the shelf that hasn't worked the first time around.
That's right. Trust that made sense for that question. And another question about if 8102 is referenced in our building codes, is the applicator going to be required to design, or is that likely pushed to suppliers or only to a certified or CSSW? It's interesting. As Stuart mentioned earlier in this call as well, we are on a path to try and bring more of an international code into that certified approach.
Yep.
At the moment, CSSW is only delivered in the UK, but it would be very much guided by that same training, same aspect. But if it was coming across as 8102 into New Zealand, Australia, which we are hoping that we are following that code, I think that we'll need to drive a lot more training, a lot more space, but also open up the industry to have more accredited persons, to have more heads thinking the same. So I don't know if you got any comments on that.
Yeah,
Sure.
it's a process, isn't it? I think the start would be to get in a standard that everyone can refer to and use as guidance. The danger is at the moment the standard's there, people are using it, but in some cases I've seen designs where people are picking what they want out of it, which isn't good because it's been misused. In regards to using the standard, I just think again it doesn't, as I said earlier, it doesn't necessarily have to be CSSW. I think we need to work along those paths of having some qualification, but the person involved needs to understand BS 8102, needs to be able to use it and not just pick it for their. For example, I've seen a design where someone's used it and they've picked type grade 1A seepage tolerable, and at the end of the day, they've used it to save costs on doing. So there definitely needs to be a uniform standard as to the type of person or specialist, and I think you just need to understand the design. You need to show that experience, and you need to understand what the design of 8102 is referring to and how to pull it apart and use it in a design. But I do think long term, yes, some sort of qualification. Some sort of industry standard would be really beneficial.
Agree. No, it's definitely in discussion for Australia and New Zealand. So, and it's well needed. Obviously, we're building a lot of structures with no guidance. And
I mean, there's so many parts to waterproofing. You're looking at type A, type B, type C, product compatibilities. You're looking at ground conditions. So having a CSSW gives you not just the experience in product type, but it gives you a little bit of geology, it gives you an understanding of construction, contamination. In the UK, we've got a lot of radon, so ground gases and that sort of thing. And that's what I say, it definitely will benefit having some sort of qualification that goes alongside. I mean, things are changing.
Yeah, in the meantime, feel free to reach out to Stuart or I, and we can point. And obviously, Stuart's got UK connections, likewise with us ourselves. A lot of leaning on there. We can pick people's brains, etc. as well. So I think it's just as much as sharing knowledge as much as anything. So very good point made by Brad. It's not always the waterproofing membrane itself or the membrane. Often comes down to quality of concrete. I 100% agree with that. The installation of concrete, the voids forming, or just care not taken at that point, and that really breaks down a lot of points. Your bond to your membrane, or if you've got an integral system or admixture type system in your concrete, your concrete still needs to be up to quality. So compaction and voids, joints, especially with shotcrete. We use a lot of shotcrete in New Zealand and Australia, and very hard to get right. So, got any comments on that, Stuart?
So, what was the actual question? I didn't get the actual question.
It's more about, or it's probably just more of a point to make, is that installation of concrete is a consideration and needs to be considered and monitored, doesn't it, as part of this, as part of getting the right result.
Yeah, absolutely. Design and placement is key. Yeah. And I mean, concrete isn't waterproof where concrete isn't. I suppose. So the key to success, I mean, you guys know concrete is joints and penetrations. So again, within the design, and having a specialist on board is understanding that part of the design, understanding where defects can happen. But yeah, it's about control. It's about the product placement and design. Yeah.
Yep. Yeah. That's good. That's a good point. Yeah, just quickly on that, so we've seen it numerous times. You know, you've spent a lot of money on a waterproofing system, gone through the design phase, only to award a reasonably low cost concrete trade or such, and you know, and they're cutting corners at that level, or a mix is not up to spec. Seen that as well, and that has been effect. So, good point from Dylan about the foreman overseer need to be able to understand what's happening to make sure it's up to standard. They do, and that's why training at beginning of a job is important. Training on the system, but also on the quality management system. So just quickly, everyone's got a similar or a system they run, but it should be transparent. They should be able to see reports. They should be able to see QA documentation and get an understanding and follow that system. So having an open reporting system where you can see photos, you can see inspection reports, non-conformance reports, all those type of things. So it's not solely coming down to the foreman that's having to say, hang on, that doesn't look right. Everyone should have a part in that, especially the installers. But got any comments on that, Stuart?
Yeah, no, 100%. It should be very transparent. Yeah, all the way through the whole process, and it shouldn't be. Yeah, I mean, the foreman's got a lot to do. Communication is key there, but when it comes to the QA process, it should be down to the supplier and the installer, and then also discuss with the site. They need to know what's going on. They need to understand what they can and can't do. They need to know, you know, the limitations of their follow-on trades. You know, even when the structure's built and the external systems on, follow-on trades will still drill through the structure. They'll still do stuff that you know, has an impact on that waterproofing, and they won't tell you. So it's important that there's a whole communication. That's going back to the team thing again. That should follow on to site, not just at the design table. So yeah, always transparent.
Cool. There's one more question. We probably should wrap up after this one, just to protect everybody's time. But much appreciated everyone's input. It's been fantastic. Just a question around: could you see the applicator being held liable for accepting a poor substrate in the way of voids or defects that cannot be observed when implementing the Type A system? So, in essence, what we're saying there is installed a good membrane on the formwork, everything's ready to go. The contractor does a poor job, or concrete quality is poor. Where's the liability lie? Any points on that one, Stuart?
I mean, if the concrete's poor, the concrete's poor, but if the water's coming through, there's obviously an issue with the external system as well. So it's got to be a combination. But the first one is, if there's a poor concrete, then that needs to be resolved. It's just bad workmanship. But then what's happened for that water to come through? Is it the poor concrete? Is that, you know, have they damaged the external system in the pour? So there's a point there where it's going to be he said, she said, we said. It's going to be hard to.
Yeah, I was going to make that point. It's a good question to raise early in your design phase, or if you're starting to go down a line with a supplier, is how's the warranty set up? Is it just the product warranty? If it's just normally, you know, they could potentially walk away from that at that point, or is it a full performance type warranty? Those sort of things where someone's taken on liability as a whole. We can't do much, like Stuart said. Once the concrete is poured, there's remedial measures, obviously, but there's many aspects that go into it. There's the steel, you know, congested steel, or what's the engineer put in there, those sort of things. Is it spray concrete? But liability does, ultimately, the waterproofing is designed to waterproofing, and normally with the liability would lie. Although, if it can be proved the concrete hasn't been gone or placed to code, that's another line to just.
I think also if you're using a combination system and your concrete is being designed as a type B, and you are expecting defects in the type A, then there's I suppose the questions have got to go on the type B. If it's allowing water through, if it's been designed as a type B structure. So yeah, it depends on design as well. But yeah, poor concrete is poor concrete. You shouldn't be accepting poor concrete in the first place. No.
Yeah, 100% agree. It's a big part.
Yeah, huge.
Brilliant. I want to thank you very much for jumping on, Stuart, and thank you very, very much for the audience. Very much appreciate all the questions and comments. They were fantastic. It does prove there is a good industry out there that's keen to help get things right. So there'll be a lot more sessions of these coming through, and we'll fire out an email. Feel free to respond, or please do respond. Actually, give us some feedback. We're always keen to learn, and pop some questions in there, like I wish you would have covered this, or you spent too long on this. That's the type of information we want to make it better for next time. So any other wrap-up comments, Stuart?
No, just thank you. I mean, it's a massive subject, and I'd love to join you on a few more of these because there's so much more to impart. And the more people on board, the more people understanding it's not just about shoving 8102 down your throat. It's about good practice and good design. It's a collaboration and it's worldwide. It's not just the UK using this, Australia using, this document is being used all over the world for its design advice. So yeah, thank you very much everyone for joining us, and we'll try and get back to some of those questions, I suppose, at some point, because I can see a few more on there.
Yeah, definitely. We'll do probably do a live Q&A. I think probably just as easy. Yeah, just pick things through. So brilliant. Thank you very much.
Thank you.